Ever spent hours modeling a perfect organic shape in CAD only to have it come off the 3D printer looking like a low-poly relic from the 90s video game? You are seeing flat, jagged faces where there should be smooth, curved surfaces. This isn't a printer problem, it's a tessellation problem. In this tutorial, we are going to fix that. At Academy, we bridge the gap between digital design and physical manufacturing. So let's dive into how to fix these tessellation issues. When you model in professional packages like Rhino, SolidWorks, or Fusion, you are working with NURBS, a mathematical representation of a geometry which has infinite resolution. But 3D printers can't read these math. They read triangles or polygons. When you export an STL or 3MF file from your CAD software, it converts that smooth math into mesh of polygons. The density of these triangles determine the print quality. If the triangles are too big, you get jagged edges. If they're just right, your print will look exactly like it looks on your screen. Let's look at this organic shape in Rhino. Go to Export Selected and choose STL. Most users stick to the default setting, but that's where the trouble starts. If we go into Detailed Control and set everything to 0 and hit Preview, look at the result. These are massive polygons. The file size is tiny, but the 3D print will be visibly faceted and low quality. To fix this, look at the maximum edge to surface distance. This value controls how far a polygon can stray away from the original NURBS surface. For FDM printing, a value of 1/100th of a millimeter is usually the sweet spot. It's precise enough that the printer won't register the faces, but the file size stays manageable. For resin printing, which has much higher detail control, you might want to go down to 1/1000th of a millimeter. See the difference? The mesh is now dense and follows the surface curvature perfectly. This process is similar in other CAD packages like Fusion or SolidWorks. When exporting, instead of low or medium settings, use custom setting to dial in these parameters. The logic remains same across all major CAD packages. And here's a pro tip. This isn't just for printing. If you have ever seen jagged edges in your renders in Keyshot or V-Ray, it's likely because your mesh tessellation was too low during the import process. Use these same principles to get those high-quality surface curvature for your renders as well. Mastering these settings is the difference between a low-quality print and a professional-grade prototype. For a deeper dive into these workflows, check out our Rhinoceros 3D Masterclass and other workshops at academy.xyz. I have also linked additional resources in the description below. If this helped you create a better 3D print, hit that like button and subscribe for more CAD tutorials. See you guys in the next one.